Three randomly selected children are surveyed. The ages of children are 1, 4, and 10. Assume that samples of size n equals 2 are randomly selected with replacement from the population of 1, 4, and 10. Listed below are 9 different samples. So here are the 9 different samples, and we want to find the population median. And our population is 1, 4, and 10. So the median of a data set, when data is arranged in order of increasing, so if the number of data values is odd, the median is located exactly in the middle. And if the number of data values is even, the median is found by computing the mean of the middle two numbers. So in this case, we have odd number of data values, so the median is going to be 4. It's the middle number. Next, we want to find the median of each of the 9 samples. Then we're going to summarize it. So right here, so we have all these samples, the 9 samples. Let's find the median. So I made a table. So for the sample of 1, 1, the median is going to be 1. So you find that by adding above and dividing by 2. So it's 1. The median for 1 and 4 is 2.5. So you add 1 and 4, get 5. You divide it by 2, we get 2.5. The median of sample 110 is 5.5. The median of 4 and 1, again, 2.5. The median of 4, 4 is 4. Again, it's the middle. It's the mean of the two numbers. The median for 4, 10, you add them up, you get 14. You divide by 2, we get 7. The median of 10 and 1 is 5.5. The median for 10, 4, again, we have 7. The median of 10, 10 is 10. So these are all the possible medians that we get. So let's go ahead and enter these. So we have a 1. We're going to arrange these from the smallest to the biggest. We have 2.5. We got a 4, 5.5, a 7, and a 10. So remember, there's 9 possible samples. So what is the probability of getting a 1? We only got 1. One of them had a median of 1. So 1 from the 9. So 1 from the possible 9. How many 2.5s we got? There's 1, 2. So 2 from the possible 9. How many 4s we have? We only have 1 4 from the possible 9. How many 5.5s we got? We have 2 5.5s from the possible 9. And how many 7s we got? We got 2 7s from the possible 9. And we only have 1 10 from the possible 9. Okay, so we have the probabilities and we have the sample median. Now, what we want to do is we want to find the mean of the distribution of the sample medians. So to do that, I can just use StatCrunch to do this. So first, let's enter our values. So I'm going to call these our x's, and our probabilities are going to be right here. So the x value, I have a 1, a 2.5, a 4, 5.5, 7, and 10. And make sure you convert the probabilities to a decimal. So 1 divided by 9 is 0.111. And the more decimals you do, the more accurate your answer is going to come out. 2 divided by 9 is 0.22. So 0.2222. And then we have a 0.111. 0.2222. 0.222. Okay, so let's find the mean. So we want to find the mean of the sampling distribution for the sample medians. Go on stat, calculator, custom. Values are the x's, the weights are in the px, and then we compute. There we have the mean. And it says, let's see, so the mean, if we round it, we get a 5. Okay, so we get 5. Now, based on the result, is the sample median an unbiased estimator of the population? Why or why not? So if a sample stat targets the value of the corresponding population parameter, the sample statistics is unbiased estimator. Otherwise, is a biased estimator. A biased estimator systematically underestimates or overestimates the parameter. So compare the values of the population median and the mean of the sample medians to figure out if the sample median targets the value of the population median. So what we got is the mean of the sample medians is 5, and the population median is 4. So they're not the same. So that means the sample median doesn't target the population median. So the sample median doesn't make a good estimator of the population median. So the sample median does not target the population median. As such, the sample median does not make a good estimator of the population median.